What is the future of seafood wasn't in the ocean, but in tanks, on land. With climate change, water scarcity, and stricter regulations, traditional fish farming is under pressure. One solution? RAS, Recirculating Aquaculture Systems. It's like a smart fish farm where water is reused, quality is controlled, and technology monitors every parameter in real time. But is it scalable, affordable, and how do we bring producers on board? In this episode, I speak with Cristóbal Aguilera, Innovation Managers at IRTA. We dive into how RAS works, why it matters, and how tech like sensors and artificial intelligence can make aquaculture more sustainable. Because tech alone won't change the industry, people will. Can we make aquaculture smarter, greener, and easier to adopt?
BlueTech Around the World, the reference podcast for blue technologies and ocean innovation. Hello everyone, and welcome back to BlueTech Around the World. Today we are exploring a groundbreaking approach in sustainable aquaculture, the RAS. This method has the potential to make aquaculture more efficient and climate resilient, which is critical as we work towards feeding a growing global population. And aquaculture is a hot topic. More than 50% of the seafood we consume now comes from farm source. And by 2050, we need sustainable ways to feed billions more people. So aquaculture offers one of the lowest carbon footprints among protein sources, and it's no surprise this industry is booming with innovation, investment, and exciting new initiatives. And as of many of you know, aquaculture is one of my favorite themes. I recently launched an association called NOAA, the Network of Women in Aquaculture. We are a social entrepreneurship initiative dedicated to promote gender equality and inclusivity across the global aquaculture industry. But let's back to today's episode. I have the pleasure of welcoming Cristóbal Aguilera, a true leader in aquaculture with over 30 years of experience in both public and private sectors. Hello, Cristóbal.
Hello, Mariluz.
Thank you, Cristóbal. Cristóbal is currently serves as the Aquaculture Innovation Manager at IRTA, where he has played a pivotal role in advancing RAS technologies and developing innovative platforms like IRTA's IRTAmar. His expertise is vast, spanning animal husbandry, fish health, genetic, recirculation technologies, and environmental sustainability. Beyond IRTA, Cristóbal has also been the AquiPlus Cluster Manager, where he helped private companies enhance competitiveness by fostering cross-collaboration between academia and industry. He is an aquaculture blogger at Aquitopia and even authored a book titled Historias Aquiculas. Sorry for my Spanish.
It's perfect.
First of all, we are honored to have you there, so welcome to the podcast.
Thank you so much, Marilu.
And just a little backstory here. I had the pleasure of meeting you in September at IRTA in the Ebro Delta Natural Park, where you gave us a fantastic tour of the facilities and shared the incredible work your team is doing. And it was during this training organized by FAO, FIAP, and IRTAmar to empower women in aquaculture industry that seeing IRTA's innovation firsthand made a lasting impression. And I was so excited for our listener to hear more about your work. So here we are. I'm really happy to have you there as my guest for this podcast episode. So let's begin with your journey in aquaculture. Cristóbal, could you tell us a few words on what initially drew you to focus on recirculated aquaculture system and aquaculture?
Okay, yes. So many years ago, but in my first stage in the private sector, I was involved in a marine fish production, basically a hatchery level, no? I remember that we have some problems with the availability and also with the quality of the water, because we are in a complicated area in which some guys we have some problems with the tides, whatever. So, and we decided to start working with RAS. We took the decision to start working with RAS technologies. We didn't so much about that. we have some notions about which is RAS. We are talking about at the beginnings of the 1990s. So, my God. But we study biology and we have some fundamentals about how we can use RAS technologies to improve. So, we start to applying these technologies. I say that it's a very elemental basis, no? Indeed, for at the beginning. And we try for the most easy for us, which is the management of the broodstock. It's quite easy to manage the broodstock because you don't need so much. You have low density, good quality in the water, and you get some other action. Later on, we have some experience, and we test with juveniles and grow. And finally, we apply the technologies till the larvae stage during the larvae productions. And, we are acquiring some experience. But also we have help from a very nice college from the trout productions and also from eel production, that they have so many experience so years ago on how to use RAS technology in these two species. And, what really was the seed, no, of the RAS technologies and how we can use all the knowledge, all the different process and adapt all these strategies to the marine environment. So at the end, due to these specific difficulties that we have in the place in which we are, RAS were the strategy that we decide to use. And this is the beginning of all that.
Okay, thank you for this genesis of your work on RAS system. And just for listener, can you give us a quick, simple definition of RAS?
Well, basically, RAS technology is based on continuous use of the same water in a closed loop. This is essential, no? It's like an home aquarium, but with a specific big differences, which is that normally we work with high densities. Okay, this is quite clear. In the aquarium at home, probably we have 0.1 kilo per cubic meter, but using RAS is from 5 to from 100 kilo per cubic meter. No, this is the principal difference. So to maintain this high density of animals in a RAS systems, we need to control basically the physical and chemical property that the fish need. And we use some biological approach, but the first one, the more elemental one, is maintain the quality of the bacterial population who live inside the biofilters. Okay, the function of this bacteria is maintain the water in perfect conditions. We support these high densities with a control of adding some mechanical addition, like mechanical filtration, like addition of oxygen, and a very, very accuracy feed control, among other things. But basically, recirculation is use the same water in a continuous loop, maintaining the high quality of the bacteria who help the fish to stay in the better conditions.
When it comes to the consistency in fish health and quality. And I just want to jump on what you were just saying before, that you were saying what was the ground of you working in RAS system. And I think that right now it's also something really important to tackle climate change, because you were saying that we need to check and to control and to monitor all these different parameters. And you were saying that at the beginning it stands for some of the most critical part of the production system, which is, for example, the hatchery. Now we can see that all these parts that are already managed on land in highly controlled environment, this ensures that this early stage development is optimized before transferring fish to open water for pre-growth or full growth, for example. But looking to the future, it's very possible that more, if not all, of the production cycle could take place on land in RAS system, even including pre-growth and potentially the entire life cycle. Do you think that this shift would allow for either greater environmental control and efficiency, minimizing the impact of climate change, for example?
Yeah, well, You are introducing so many concepts at time. Okay, for example, RAS technology is not only a strategy because of climate change. As you say, it's a consequence of many different factors. Okay, one, for example, is the availability that we have of the coastal space. For example, we don't have the spaces to do that. Later on, actually, the amount of water that we have, water from fresh water and also marine water, but because you need to pay for collect the water and you pay for reject water. So this is not so easy and it's complicated. Also, it's quite important that you say the control of the process of the standardization of the production process. This is really important. Diseases, sanitary control, possibility also to approach, for example, the production to the main market inland, not only outside, reducing the transport costs, reducing the cost of production, and also, and obviously, the effect of the climate change is real. And we can observe this one in the temperature that we have in the water, the amount actually of continental water that we have available, of new diseases, new legislation, all the one play a complete role. So apply all this knowledge that we have and how we can RAS can help in this one is actually a reality. It's a reality. In fact, we can find the control of the broodstock, we can find some companies who produce at hatchery level, applied in RAS technology, in pre-growing and also of growing. Not all the places, not of the species, not all the knowledge that we have is actually available to do all this in these specific facilities using this kind of technology. I can say that RAS is a complement of the actual model, the standardized model that we have, but it's not like a complete solution for all that. It's just a help. For example, some years ago in Chile, they have some problems with diseases, okay? Basically, all the production in Chile is salmon, and they produce salmon like in Norway, like in Scotland, and other places, in the big fjords that we have in the south of Chile. Once the legislation changed, the new facilities it's possible to build in are based in RAS. And the government say, yes, of course, I can provide you a new authorization to do hatcheries, but all the hatcheries will be building using RAS technology. So, for example, it's a mix between one another.
Okay, yeah, so not like a complete system, but complementary, depending on the needs, the benefits, the spaces, and the localization. Okay, got it. You already give us some parameters, but what are the amount and kind of parameters you can control in a RAS setup, and how does this can influence fish health and growth? You were talking about the temperature, for example, but can you give us more example on that?
Yes, it's quite important that understand that the fish need to a stable condition to improve, no? Only, and also maintain the welfare, no? Fish need a homeostatic environment. Now, homeostatic environment is in which the difference is at minus that's possible. Fish need this homeostatic situation to invest the energy in growing and not invest this energy in fight again, I don't know, all the external aggression that they have coming from, I don't feel well, I don't feel good, I can't eat it well, so I invest so many energy in solve this problem in order to eat and grow. No? Why? Because fish are poikilotherms. And the more elemental parameter that we need to control are temperature, really. Temperature is essential because the fish are happy in the temperature in which they are moving, because they are in a closed system, they can move in, they can go looking for another species in which they are more comfortable, no? And also because we are working in a closed system, we don't have not so much new water, etc. We need also control the oxygen level. This is essential. The oxygen level and the temperature with the flow rate and the amount of recirculation frequency. these parameters, oxygen, well, the temperature is essential, we say, the new amount of water, the frequency of recirculation is essential to maintain the metabolites existing in the closed system. And one of the more worse for the fish is the amount of ammonia, okay? And the ammonia is critical, but the criticity of the ammonia is based in the pH. So ammonia, pH, temperature, water, amount of water, and I would say flow, they are the more elemental. Obviously, with the control of feed, because all is integrated. They are existing others, but I think this is more or less the essential one.
Okay, so if I sum up, you need to make the best environment for the fish to feel the more comfortable, the less stressed, like that he can concentrate and focus all his energy on growing.
Yes, basically the fish only need two things, feed and oxygen. The oxygen is coming from the water, but if the water don't have enough oxygen, we cannot feed. So if you maintain this condition with the elemental thing that the fish need for growth, it's fantastic. But it's not too easy. Only control this one. It's a mix of different parameters that helps to the fish will be in the best environment, and this affects obviously to the welfare of the fish. Yes, exactly.
Okay, so you were talking about a lot of parameters, temperature, dissolved oxygen, pH, ammonia. So I'm assuming you have a lot of multi-parameters probes in the ponds. How does it work exactly? I'm assuming that digitalization and IoT is helping you building this new digitalized RAS to help you monitor all these parameters. How does it work exactly?
Well, let's say digitalization is really a need, no? Because in our case, and basically all the companies that use RAS, they have many different probes. Probes like temperature, ammonia, pH, amount of new water, exchanges, some other things. So you need to connect, you need to use all the data and transfer all the data to a control platform. And in this platform format is take the information to be sure that all really is working well. No, actually, we not only use different probes, we also use the information coming from the data that we acquire for these probes to monitoring in real time the information that we are obtaining, and we have the possibility to adjust the parameters obtaining information at this moment. For example, you have a temperature probe, okay? And you say that the temperature I like to maintain in my fish is 20 degrees. And we have an hysteresis of minus, 2 degrees. So the system this probe is connected, for example, with a heat pump who offer you the possibility to increase the power to heat the water or reduce the water to adapt as much as possible the temperature that the fish is. The fish don't like pigs, okay? Pigs is probably one of the worst things that the fish, because they need, like they say before, they need to fight continuously. The very few modification of the system is better because we are concentrated. And in fact, actually, we're having a very nice project in which we are changing the usual probe, the standard that we can find in the market for many different uses, not only in aquaculture, from agriculture of other things. And we can actually, we are trying to adapt these new neuromorphic nets, which are many different chips integrated in one probe. Every chip had the possibility to detect one signal, and this signal is associated with one parameters. So a lot of different parameters in one probe connected with a high level of AI technology. The idea is we are doing now is how we can train the system to understand from the data that we are obtaining in the different scenarios. So it's a very nice possibility, no? And this implies, of course, as you say, a high level of digitalization in general.
Okay, so if I sum up, there is the basic one is that it is already really useful, which is the real-time monitoring and adaptation. So if there is a threshold, for example, of temperature where we go over a specific data, you can adapt the environment of the water, for example, the temperature of the water. So that's the first one that is really important, actually. And the second one that you were mentioning is that you can train this data that you are collected in real time to make some predictions. So I think here artificial intelligence with having all this data and making scenario prediction forecasting help you adapt and think how things going to evaluate in the environment. So I'm thinking about one specific application, for example, the planning of the feeding. If you know that the dissolved oxygen is going to be this in the next few hours, perhaps it's a good timing and you can make your team do the feeding at this specific time. Or do you see other application? It's the ones that come in my mind right now, but...
No, that's fine. That's right. For example, actually, with the level of knowledge that we have and the technology that we have applied to the RAS, we can know so many things about this. For example, we know how to feed because we have indirect information about the amount of ammonia or the amount of metabolite that we have, or if the pH are or not moving so much. So they are direct indications to do some actions. But this is consequent of one actions. The idea that we have now is training the system to advance the proposal before that we have the data. For example, if the system detects that some specific, I'd say, indication that the ammonia is now in a process of variation, the system say, probably you will have a problem. So, please, I recommend you reduce the amount of feed. Or I recommend you stop the feed, or I recommend you these actions. This is based of the historical data that we are obtaining, based of many different data that we are obtaining for many different scenarios. There exists the possibility to advance the problem, not just in the moment, if not before that they will be arriving. This is actually in which we are working.
So it's really a support decision tool on how to help the manager of the farm or the production to make better decision in the future and to anticipate what he has to take. But one question, you said that you have to train the model to make this forecast and anticipation. So for example, what you are doing at IRTA, if I want to do it in another farm, can I just take your model and put it in a new farm, or does he have to train with the new data at the beginning to make it really personalized to this kind of species, this kind of environment and parameters? How does it work exactly?
Well, actually, this is a project. Okay, we are working with this new probe. We are testing. Is a pilot approach, but yes, the idea is to apply this knowledge for every species in every stage and in every conditions. Okay, doesn't matter if you have data. If you have amount of data, you can transform the data into actuation. This actuation is necessary to transform into value. The value is how to do that in my farm and how we can reduce the possibility of mistake. Okay, maybe next year we have the opportunity to present in the public the new intelligence, the artificial intelligence adapted to RAS to improve the production of so many fish. You know, research is that, no? In some cases you advance quickly, in some cases you need to adapt more, but well, it's quite promising for the moment.
This is really promising. Thank you, Cristóbal, to know that this kind of innovation and technologies are, in research right now and maybe in the market in the near future. So thank you for this insight. And actually, it's a perfect transition for something that I think is really important regarding RAS is the knowledge transfer and the industry adaptation and adoption by the actual farmers. I know it's not really easy to scale RAS to more producer. In your opinion, what are the most important challenges in making this technology accessible to a broader audience?
Well, depending of the audience, no? Okay, this is not too easy. In general, we found that when we connect with our potential users, okay, we are talking about the technology that we are developing. Is RAS, okay? which is a RAS that we apply to improve research. Okay, we can also apply to farmers, producers, or whatever. But we detect that some of our consumers say that they need easy things. Okay, they don't need so much complication about the control of the different parameters, how to work the RAS. It's like the return to the basics. Okay, we need to be sure that I am doing the things well without any problem. So this is the basics of how we are designing our technology. Don't worry about the parameters. Don't worry about how to follow the parameters. You only need to know that all the systems work well. You need to know which are the fishes, they are eating well, etc. And also because I see that so many users, technicians or researchers, have some fear about the use of RAS technology. It's not the feeling, well, they feel comfortable because some pros, some technology, doing different things. We can do that, no? And in general, I try to offer this, to say, don't worry about that. Technology works. We have under control. So I provide you a powerful tool to help you in the sync of your experiment, on the data that you are obtaining, and focusing that, because we are expertise in provide you these kind of solutions. But
okay. So trust the process. We are the one dealing with research and development. We are expert on that. You are the expert on the production. So trust the process. We give you a good solution. Even if we are a podcast dedicated to innovation and new technology, it's always important to know when it's go to the market. So about the business, I was wondering if like the cost or the training needs are also one of the constraints for the adoption by the industry, or how do you see this economical pain point for a RAS system in balance with the true benefits that you demonstrate at the beginning?
Well, depending of the model of RAS we are using and how to apply this one, obviously they have different cost production, cost energy. In general, I think that RAS technology is clearly a very useful technology, for example, to maintaining high-value stocks of fish, like broodstock. Or, for example, if you are in a program of restocking with very values fishes in very controlled stock and you need to reintroduce it. Or also if you are doing a high-level research and you need to be absolutely all under control. So in these cases, you need RAS system with the capacity of obtaining so many data to be sure all the process is already, all is okay, you don't have any problem or whatever. But when you scale from the research of the high-value stock to the productions, you need to apply other things. In other things in which probably is not so essential this kind of parameters or the frequency of the amount of data that you have, that you need to be sure that the elemental parameters, for example, energy consumption, oxygen that you are using, the quality of the water, the potentiality of some diseases associated with the system, and how we can feed the fish to obtaining the maximum profit are essential. So you need to put all the effort in this. And of course, it is economically, cost economy is absolutely fine, because you are doing that in a specific area or in a specific place in which you don't have other options. If you don't have other options, the cost is inherent of this one. No, for example, you don't have water, or the quality of the water that you have is not enough. Or, for example, the species that you are producing, marine species, is online. So you need to use this technology. All depend on the market, okay? All depend on the possibility to put your product in this market, that they pay for that, etc. But as you say at the beginning, aquaculture actually is a reality, is a need. More than 55% of the product that we are consuming come from aquaculture, and all the alternatives associated and how aquaculture can help to produce high quality blue food is essential. So
Okay, that's really great. And I think that, as you were mentioning, that cultivating a culture of innovation is really essential for RAS to progress. How does you in IRTA encourage innovation in aquaculture?
Yeah, it's quite important. Sometimes when I ask me about that, I say that innovation is not a question of luck. No, no. Innovation is not magic. This doesn't appear from nothing. It's not an invention. No, no, no. It's a discipline. You need to know exactly which is this discipline of innovation. And the more elemental things to apply these disciplines is the strong desire of change. Because, change is essential, because if you don't like to change, you don't apply the discipline. If you don't apply the discipline, innovation is nothing. In this sector, aquaculture, in which the change is not only technology. If we think about that, if we have a good technology, we can change. If we can change, we have innovation, it's a mistake. Innovation is in the people. We need to train in the people. We need to help the people to acquire all this new knowledge of these capacities, to apply all these capacities in this specific discipline. And at the end, as you say, innovation is not other thing that transform your ideas into value. And the value is necessary to arrive into the market. And we also kind of take some return for this innovation, because probably you have a fantastic idea, marvelous idea. Some years ago, we are detecting something. In many cases, before doing innovation as a discipline, it's necessary to train in the people in this field. It's necessary to introduce the culture of the innovation in the organizations. We are preparing some specific courses, not only for the people in charge of technician, basically in most of the cases for the people in charge for take decision, and also, for example, in the research involved in. You need to know, you need to understand which is the culture of innovation and introduce inside your company to be sure that, okay, all the people are aligned, all the people know exactly what we can do. I mean, in some cases, we have a surprise, no? The most powerful innovation come from your own people, because they have some idea, they know about that, they stay passing so many days a day working with fish, working with RAS system, and we are introducing so many new approaches, different kind of, innovative ideas, only hearing the people. They say, what do you think about that? Well, I think that probably wonderful idea. How to do that? What do you think of this? Fantastic. This is culture of innovation. This is essential, yes.
I really like this idea of culture of innovation, and what you are mentioning, that innovation is not only technological, but it could be human and social, and that building this mindset of innovativeness and change, and that in any company, structure, research laboratory, we have this vision that we are aligned, that we can make some suggestion and build upon what we do daily on a lab or on the market, and suggesting some new ideas. So I think it's really important, and that is not only applying to the aquaculture industry, but to any kind of industry. We will not need to think about these are the people who do the innovation and these are the people who do the operation. No, everyone has to be part of the innovative process. Everyone has some innovative ideas to share. So I think it's really important to have this idea of importance of multidisciplinary skills in innovation, and this resilience and discipline that you were talking also about, because even if you have a lot of ideas that are good, sometimes you need disciplines and structure and organization to make these big, brightful ideas come to life with innovation and new technologies. So yeah, thank you for that. I think it's a really important point, this idea of culture of innovation. Okay, so let's switch now to the market, because we were talking about the innovation, the producer, but also the different stakeholders of the aquaculture industry. But I was wondering, how do the consumer perceive fish raised in RAS system? And, how do you promote or disseminate or communicate about this for education about RAS system and seafood consumption?
Well, talking about consumer, I'm not so sure, but I think that the consumer in general don't have so many ideas about the RAS technology in particular. they have a global idea about the industry of the aquaculture. Okay, when you talk with which is aquaculture, that the people know, they have some ideas about the farms. Okay, the fish inside cages or inside or whatever, but technology per se is not exactly that the people associated with the process of production. Is in general. But maybe, I don't know, maybe I have a mistake about this concept, but I think that the misconception is based in the industry in general, not in specific technology.
You're right, actually, because there are some countries that wanted to create brands. I'm thinking of Greece, for example, brand Fish from Greece, where you can find fish from RAS system for open sea farms, land, whatever. And actually, what's the main concern for the consumer is if it's, for example, sustainable, if it's organic, and feel like that, rather than which technology is used on that. So I think it's really important to have this collaboration among the different farmers and technology to build a strong communication about seafood and aquaculture. So that's one of my thinking on that.
No, let me say, and this is absolutely essential. In fact, 1 year ago, we finished the New Tech Aqua project. This is a big project in which we are involved in how to apply new technologies to improve the aquaculture, not only in the Mediterranean, in different areas. And we do a lot to transfer the knowledge that we have to the consumer, but not all the consumers. I say, which is the target consumer that we have? The children's, because the children's are the new one consumers in the future. The children's need to know how we are doing the things, with technology we are using, how to do that. Different people of the consortium, what's involved in develop a toolbox, plenty of games, of ideas to transfer to the teachers how to apply all this knowledge at the school level. Okay, and also, for example, I remember that we building aquaponic model based on RAS technology, very easy to building at the school. And we do some that. We go to the school and we build a very small aquaponic system connected with a pond, with fish, with plant inside, and try to introduce to the children that technology, aquaculture. Yes, this is important. In fact, this project was really awareness. It's one of the most awarded projects in EU for how to transform the knowledge that we develop and how impacting the society in different kind of levels is necessary. If we don't provide to the consumer enough information about the system that we do, they have doubts. And they have doubts, it's easy that fakes come in, and the people prefer the fake because it's more easy to understand than the reality of the feeds. And the reality of the feeds is RAS is not easy, it's complex. But it's not a fake, it's a reality. But if the people think that, I don't know, the fish in RAS has totally monster, this is a disaster for the nature, whatever. The people who work in produce feed for the world, feed for whatever, to try to approach the idea of how technology improves the quality of the food that we are eating is not to the contrary. It's a value. It's valuable.
No, I fully understanding like how to disseminate and to make technology understandable applying to food system. And I really love the idea of teaching to the next generation of seafood consumer how it works. I know that there are also some good work made by the FAO and the FIAP, the Federation of European Aquaculture Producer, on how to train this new generation. And myself, when I visited you 2 days before, I was at sea on a farm with IRTAmar, looking at the sea bass and sea bream on the sea. And after we did a cooking class, and it was really amazing because we were really like on the field looking for the concept of from the fish, the farm to the fork, really seeing the fish in our hands, in the sea, and then in our plates. And it was, I think it's also really important to be in the field for the children, but also for me, a big child, to see what's actually aquaculture is. And I think it's really important, as you were mentioning, to see to open the door of the farm, of the technologies to make aquaculture more concrete for the next generation. thank you for this insight. I just wanted to ask you, like, looking ahead, what new development do you foresee shaping RAS in the coming years?
Oh.
Tricky question, I know.
Yeah, yes, it's how I imagine, no? That for me, I don't know. For example, my ideal, no, for RAS technology is technology easy to apply, okay? That you can apply in every place, depending of the sources that you have. If you have few amount of water, you can adapt the technology to use this water also. So technology can help you to maintain this one cheaper. This is important. If it's possible to reuse as much as possible all the elements that you have. If you reduce the amount of inputs, if you reduce the amount of water, of course, you reduce the amount of outputs. If these outputs, you can reduce also the effect on the environment. For me, this is essential. Okay, it's like another industry in whatever place in which you are controlling all the process, and it's necessary to do this one. Later on, of course, we have technology. We know that we can introduce so many parameters for control using different kind of process. So I think my concept is say, okay, always under control, or basically we can control the parameters. Okay, take care about that. And also I imagine the RAS technology integrated with another additional system, like for example, IRTA system, integrated multitrophics, for example, helping or use the outputs coming from to produce algae, macroalgae, microalgae, or for example, we know some companies are actually using the sludge coming from the biofilters for produce insects. So, and elevated the use of RAS technology to the full circularity concept. Okay, reduce the spice, reduce the amount of input, reduce the energy, reduce the cost, be efficient, no big constructions, the level of adapted for each necessity, and also integrated with so many other possibilities. And in places in which it's really necessary. For example, in places in which you don't have resources, you have a scarcity of water, you have problems with the temperature, but you need to produce feed, and it's more cheaper produce and produce high quality jobs in this area that import all from outside, because at the end you are doing nothing. It's a mix between technology and social approach, ethic, and also environment control of the main parameters. This, okay, I would like to see so many.
Yeah, so many topics, and I like the way you see that it also lead to the democratization of the system and the capacity building and job and employment of the people working on the sectors. But also I really like the integration on a more circular approach as RAS as one of the components, if we want to work on IMTA, for example, on how to use it as part of the system. So yeah, really, I share your vision of RAS system, and I'm sure it's going to be one of the key solution for feeding the planet, if I come back to my introduction of the episode. So
this solution can help. It's not the solution, of course, I am sure, but it's part of that.
Before we wrap up the episode, is there any specific topic or project that you want to share? That's something that you think will be really interesting for our listener?
But for example, I say you before this project in which we are involved, which is quite interesting, how we can apply artificial intelligence to help us. Our partner in this IRTAmar, which is the technology that we are developing, are in Ingeson. Ingeson is expert in control and automatization process. Now we are working in how we can apply this knowledge that we have to the new prototype of IRTAmar. The idea is also add some slides of technology to our IRTAmar to control all the parameters, to advance and help to the farmers or the researchers to take decisions and also to provide a complete software on how to do that. How you can do an experiment with fish, with marine fish, I don't say, bring with these sizes, with this feed, or how you can control the parameters if you are growing this kind of fish, on how you can do the reproduction of this brostock. So now we are working in this, and next May, Aquaculture 2025 in Vigo is a very big conference, no? And the idea is present the new prototype of IRTAmar, integrated all this knowledge inside the new platform that we are developing. Not only do RAS with a clever approach, with intelligence, and the possibility to, it's like, I could to say, like a Lego, no? You have the essential pieces, and depending on the pieces you use, you have a plane, you have a car, you have a whatever. So this is the idea. Depending on the use that you do, you can do recirculation in continental, you can do recirculation in marine, with flatfish, with fine fish, with crustacean, or whatever. This is the idea.
Like you go to shopping, I need these spaces, I want to monitor these parameters on this specific environment. I love this idea. So I'm looking forward to seeing that in Vigo.
I think it's a nice project that we have. Well, no, we are testing now. We know this is work. And the idea is present with all the potential complements that we can add. And, learn about the needs of the people and how we can apply these needs. Because, IRTA, no? IRTA is a very powerful institute. We have so many different times. We have so many different facilities. We make a lot of mistakes. We are learning a lot of the mistakes. We have 48 different RAS systems with the small fish, big fish, marine, continental. So we are continuously improving. We are testing whatever new things. And for us, our real clients are our research, that they are asking us continuously new things. For example, hey, what do you think if I do that? Oh, we can do that. So we try, we test. And when we are sure that doesn't work, etc., we incorporate inside our system. And this new incorporation, this new approach is available for whatever.
Yeah, that's good that you have the infrastructure, the people, the expertise, and that you can answer the different question of the industry or your or other researchers asking this kind of combination. And after putting this data on the whole system and making more intelligent and smart and learn. So that's great.
Exactly.
Okay, Cristóbal. So as we wrap up, where can our listener go to learn more about you and your work? How can they get in touch with you if they want to ask you some question or follow up after the episode?
Okay, it's quite easy. You can introduce my name in Google, Cristóbal Aguilera. I am very well positioned in the top of Google. Directly by my email or by LinkedIn, and also directly by my blog. You are totally invited. You can go inside and send me whatever need do you have.
Okay, great. Thank you, Cristóbal, for such an insightful conversation on RAS and sustainable aquaculture. So for our listener, all the information on how to reach Cristóbal and learn more about his work with IRTA and RAS can be found in the episode description. And thank you all for turning out to BlueTech Around the World. As we are just launching the podcast, your support means so much to us. So if you enjoyed the episode, please like, share, and leave a comment. We'd love to hear your thoughts and feedbacks. And don't forget to share it with your network or that friend who is always talking about the sea, fish, boat, or the latest in ocean tech. They will love it. So thank you again, Cristóbal. It was a pleasure having you in the podcast.
Thank you to you, Marilu. It's really also a pleasure for me. It's very interesting questions. Not too easy to answer in some cases, but yes, fantastic. Thank you so much for sharing this time.